Good morning, everyone. My name is Devarshan of CSC B section. Examples of continuous property distributions. The normal distribution. Changing mu shifts the distribution left or right. Changing increase sigma increases or decreases the spread. The normal distribution as mathematical function. F of x equal to 1 by sigma root 2 pi into e power minus 1 by 2 into x minus mu by sigma whole square. Note the constant symbols of sigma are the value of pi is 3.14159 and the value of e is 2.718. This is the bell-shaped curve with different centers and spreads depends on mu and sigma. It is property function so that no matter what the values of pi, mu and rho must integrate to 1. Integral minus infinity to plus infinity 1 by sigma root 2 into e power minus 1 by 2 of x minus pi by sigma whole square dx equal to 1. Normal distribution is defined by its means and standard deviation. E of x equal to mu equal to the formula which I said before. Variation equal to sigma square, that is minus infinity to plus infinity x square of 1 by sigma root 2 pi into e power minus 1 by 2 of x minus mu by sigma whole square of dx minus sigma square. Here mu means mean of the problem. Standard deviation is the root of variation. The beauty of normal curve. No matter what, mu and sigma are the area between mu minus sigma and mu plus sigma is about 68%. The area between mu minus 2 sigma and mu plus 2 sigma is about 95%. And area between mu minus 3 sigma and mu plus 3 sigma is about 99.7. Almost all values fall within 3 standard deviations. 68 to 95 to 99.7 rule. Here, the blue value stands for 68 and the green one stands for 95 and the last red one stands for 99.7. And the whole graph is for 0.5 and the values gives the whole thing. You can see the values 68, 95 and 99.7 have the own formulas. How good is rule for real data? Check some example data. The mean of weight of the woman equal to 127.8. The standard deviation SD equal to 15.5. So here the average stands for 128.7. The percentage and pounds are 80, 90, 100, 110, 120, 130. Half is 112 and the other half is 143.3. 68% of 120 is 68 into 120 equal to 82 runners. In fact, 79 runners fall within 1 SD, that is 15.5 lbs of the mean. Here, 96, 128, and 158.8 are the values, and 95% of 120 is equal to 95 into 120 and 114 runners. In fact, 115 runners fall within 2 SDs of the mean. Here, the midpoint is 127.8 and the other points are 81.3 and 174.3. 99.7 of 120 is 99.7 into 120. That is equal to 119.6 runners. In fact, all the 120 runners fall within 3 SDs of the menu. Example. Suppose SAT scores roughly follows a normal distribution in US population of college-bound students with a range restricted to 200 to 800, and the average math SAT is 500 with a standard deviation of 50. Then 68% of students will have scores between 450 and 550, and 95% will be 400 and 600. 99.7 will be between 350 and 650. But if you want to know that math SAT score corresponds to the 90th percentile of equal to 99% students are low, and P of x less than Q is equal to 90, the formula is equal to Q tends to 100, 1 by 50 into root 2 into e power minus 1 by 2 by x minus 500 by 50 whole square. Differentiation is equal to 90. Solve for Q. Standard normal Z. Universal currency. The formula for standardized normal probability distribution function is P of Z equal to 1 by 1 of 2 pi into e power minus 1 by 2 into Z in minus 0 by 1 whole square is equal to 1 by root 2 into e power minus 1 by 2 Z square. The standard normal distribution. All normal distributions can be converted into the standard normal curves by subtracting the mean and deviation by standard deviation. So it is equal to x squared mu by sigma. Somebody calculated all the integrals for the standard normal and put them in a table, so we never have to integrate. Even better computers now do all the integration, comparing x and z units. Here, 100 is starting point and 200 is the ending point, where mu equal to 100 and sigma equal to 50. Mu equal to 0 and sigma equal to 1. Example. What's the probability of getting a math SAT score of 575 or less? Mu equal to 500 and sigma equal to 50. Z equal to 575 minus 500 by 50 equal to 1.5. That is, the score of 575 is 1.5 standard deviation above the means. This is the formula to find the P of x less than or equal to 575. But to look up Z equal to 1.5 in deviation chart or enter into SAS, no problem. It is 0.93.33. Practice problem. If birth weights in a population are normal distribution with a mean of 109 O's and a standard deviation of 13.0 Z, what is the chance of obtaining a birth weight of 141 or heavier when sampling birth records at random? What is the chance of obtaining birth? From the chart of this is the solution for the problem. For the 120 minus or lighter, 128 minus 109 by 13 is equal to 0.8. From the chart of SASZ is 8.5 corresponding to a left trial area of z less than or equal to 0.85. This is the graph of probability standard normal table. What is the area to left of z equal to 1.5 in a curve standard normal curve? You can see here 1.2 and 0.01 in this is the value of 1.15, that is 0.9345. The area is 93.45. Data null. The area equal to prob null 1.5. Put the area run. If you wanted to go the other directions, that is from the area of the z score, called the so-called prohibit function. Data null. The z value equal to prohibit 9.3. Put the z value run 1.4757491028. The prob norm function gives you the probability from negative infinity to z, here 1.5 in a standard normal curve. The prohibit p function gives you the z value that corresponds to a left tail area of p, here 0.93 from a standard normal curve. The prohibit function is also known as the inverse standard normal function. Prohibit function, the inverse. Are my data normal? Not all continuous random variables are normal distribution. It is important to evaluate how the data are approximated by a normal distribution. Data format class. Average users of coffee and percentage of coffee. This is love of manuscripting writing. 10 equal to height and percentage written in the love. Moderate to intense exercise. Hours in a week. Wake up time in the AM, that is calculated in 7, 7, 4 and 7. Coffee. 0.3 members drink the coffee just in the time of 6 a.m. so that it refreshes their mind. And others drink coffee 8 to 12 p.m. so that they go to work and can do anything. Some of them need coffee so that they can also have a good day. Normal private plot. Wake up time 5 a.m. Then it gradually rises to 9, closest to a straight line. Format test of normality. Results. Coffee P less than or equal to 0.2. It all comes back to Z. Thank you.